All right, good afternoon, everyone. I'm John Woodell, and I'm here with Charles Nutter today. He's been working on a new language called Mirah, which I've been working with, and Ryan Brown from Google has also been doing some work with it. And we're real excited to see where it's at today. Take it away, Charles.
Okay. Well, hi. This is my first Tech Talk at Google. It's fun to be here. We'll jump right in. I write Java code all day long to work on JRuby. I write Ruby for libraries and for little side applications on occasion, but largely I write Java all the time. I do little JVM utilities, usually surrounding JRuby or for JRuby. I do lots of bytecode generation. It's amazing when you're able to write like 50 lines of bytecode generation and it just runs the first time. That's kind of a scary moment. I've got interest in doing mobile and embedded applications. I've done some really small, like sub-ME embedded Java stuff, where like I had to write my own streams and stuff. Fun, but I've got a fairly narrow scope, and within this narrow scope, Ruby has a little bit of trouble fitting. So my problem is that I really do like Ruby. I like the syntax. I like the feel of the language, but I write Java all day long for JRuby. Is there a way that I could start using more Ruby? I mean, we can get Ruby to run really well, but it's going to be hard for it ever to replace, on a performance level, on a footprint level, what we actually do with Java. So the idea for Mirah started like this. What if instead of writing this Java class with all the extra noise that comes along with it, what if instead of writing this, I could actually just write this and lose nothing at all? This is the Ruby class version of this, okay? And that is essentially what we're doing with Mirah. So in Mirah, we're pulling features from various languages. We're pulling syntax from Ruby, the bits and pieces that we like. We're doing local type inference like Scala, and actually some field inference here. And the goal of this, let's take a look. Mirah is kind of, at the moment, like a nicer way to write Java. It's Ruby syntax with a few modifications, like type annotations for parameters coming in. But it ends up feeling a lot like Ruby and compiles directly down to Java or to JVM bytecode. And you can produce Java source with it as well. That's one thing we've been doing, is keeping feature lockstep so you can generate both Java bytecode and Java source for the equivalent thing. But the key feature here, and I think this is one that has escaped almost all other JVM language implementers, is that we're really working hard to introduce no runtime library at all. The code you write compiles to class files, and that's it. You're done with it, which makes deployment on small devices, deployment on mobile devices, obviously much, much easier. So let's dig in a little bit on this. So features from Ruby that we do have working. Optional arguments. I can show an example of what that looks like. Basic internal iteration. Closures are functional now. Most of the literal types from Ruby. String interpolation is nice to have. We have plans for things like mix-ins and open classes. Those will be coming along. There's other features that we want to pull from your favorite language of the week. For example, extension methods, doing it something like C# does, but making it look like you're actually opening classes in Ruby, right? Implicit type conversions, possibly from Scala, which opens up a lot of dynamic DSL sort of stuff without actually changing any of the static typing behind the scenes. Pattern matching in case classes. I mean, there's all sorts of stuff that we could do. And I think we can do almost all of these with just a compiler and not introducing any new libraries. That's the goal. That's the goal right now. So let's see what this looks like in practice. Here's a simple, the hello world from Ruby and the hello world from Mirah. Identical code, except that this Ruby version is going to require you to immediately ship a 5 or 10 megabyte JRuby jar file along with the application. Hello world has now encumbered you with that library. In this case, there's no other dependencies. So this is the basic code that we end up generating, the bytecode we generate for the Ruby stuff. And in here you probably can see that there's the call site logic, there's some preamble logic, and this isn't even the whole story. The call site logic is going to pick up the puts method from somewhere, it's going to construct the string from somewhere else, and then it's going to do that call dynamically. If you do this with Mirah, we're essentially just turning it into system out print line. Same code, but compiles straight down to regular bytecode and does what you really want it to do under the covers. And then the Java code that we generate. So we have Mirah just spitting out regular Java code that does basically what you would write if you're going to write it in Java. Another example, we go back to fib. There's the Ruby code. There's the only change required for Mirah. Now, of course, you can't, there's no way you can read this. There's about 6 different call sites in there. It's constructing all the fixed num objects, doing all of the dynamic calls in there. We'll be able to improve this with some of the dynamic optimization stuff in JVM, but it's still a lot of noise and a lot of overhead. The bytecode for Mirah. Essentially, it's almost identical to what you would have if you wrote the code in Java and compiled it with Java-C. And then the Java code, of course, which is not the most beautiful thing yet, but we can always pretty print that or something. Optional arguments. Now, of course, in this case, we probably could infer that both of these are ints and just go with that. At the moment, the way that the optional argument syntax works, we do have the type on there as well. And here's just the Java code for that. Chaining the methods just the same way that you would if you wanted to create a series of overloads with optional arguments. The Ruby code for simple internal iteration. Mirah code is essentially identical. And there's the Java code it generates. And you'll see we're doing the same thing as Java 7 at this point, creating an unmodifiable list of those values, and then doing like a Java 5 for loop, pulling the iterator out and doing all the iteration for you. But it looks and feels like you're actually doing a regular Ruby iteration. So things like each and map and select and whatnot, they're all available just by using the existing patterns of what works on the JVM without extra libraries. A simple closure. So here I'm actually creating a new thread with the closure, and the logic there is just to print out some text. Again, same thing in Mirah. And here's the Java code we generate for it. So digging into this a little bit, we're creating a little binding class that's going to hold the mutable closed over state, and then creating a little runnable class, both as little inner classes, all behind the scenes. So closures in this case end up just being sugar over doing anonymous inner classes. Anywhere you've got a single method interface, you can just have a closure, a block of code. And it infers the types of the arguments, infers all that stuff, looks like Ruby and feels like Ruby, but it's actually just doing all the noise of an inner class that you would normally have to do. Okay. So now it's important to point out that this isn't Ruby. This is just using Java's library. It's basically Java's type system. You don't have things like eval and mutable classes. We can make it seem like you're opening classes up, but it's not Ruby. It's a lot of the things I really liked about Ruby, the apparent features of the language on top of Java. So I can use those features, and nobody really even needs to know I'm running Ruby. And actually, you could have like a commit hook that generates the Java code if you really want. But that's the thing, it feels like Ruby. All of these features that people talk about that they like so much about Ruby, in 90% of the cases, they're surface level features. They're skin deep, just syntactic sugar, syntactic niceness. And you hear a lot about new languages that say, well, our syntax is just as nice as Ruby. And it just seemed logical to me, why don't we start with Ruby syntax and see how far we can go to compile it down to the fastest possible bytecode, no runtime library. We'll see how far we can take it. All right, so now a little more fun with Mirah, just to show a little bit more interesting code for this. There's an application for Android called Garrett, written by Phil Hagelberg. It's kind of a playing around with Mirah. So let's open that code up and see what it looks like. All right. So I've got all this application noise around it and one file here. Let's make this a little bigger. All right, so we'll walk through this a little bit. Now, obviously it looks a lot like Ruby, right? Because it's just using Ruby syntax and Ruby parser. We've got a few imports. And from here on down, the only things that are really going to be different from if you were to write this actually in Ruby code are anywhere we have to clarify or narrow it or cast a type. So here we're declaring the variable A is a context, Here we're making sure that these are stored as floats in what essentially gets inferred as fields on this class, x and y and radius. And the rest of this is all pretty much just Ruby. We've got the bounce logic. You're starting to get curious about what this does, aren't you? Move. We've got the touch events we're doing stuff with. Release, what does that do? Historical X. Oh, so we're tracking some stuff, tracking some deltas. And then drawing circles, drawing some text on it. Let's actually see what this application looks like. Now, it's actually interesting to note this, again, this is all the code. You compile this and you get a couple class files out of it. No additional dependencies, no external dependencies other than all the Android stuff you're using, right? And it looks nice. If you like Ruby syntax, this is pretty clean stuff. All right, let's go find this app. Garrett. I have no idea where you got that icon from. Okay. There we go. So let's play our little game. Actually, this used to be just a bouncing ball, but I thought I'd turn it into an interesting game. So we're going to grab this ball and just throw it as hard as we can. Okay. There it goes. What's my score? Still going. 31, 32. I don't think it's going to make it. 33, it looks like. I think this version I've still got it limited to a velocity of 50 max. But, oh, it did make it. Sweet, 34. Okay. So let's go back to the code in the app. And like this, again, this is all Ruby. But when you compile it down, let's see how big these applications are. If you were going to make an application like this with JRuby, for example, and ship it, you'd need to strip a bunch of stuff out. The JRuby jar is anywhere from 5 to 8 meg, depending on how it's compressed. The DEX process can strip it down a bit more, but you're still going to have to ship a pretty big application. I think that Rubato IRB app clocks in at about 10 meg. And it's in the marketplace, so you can install it if you like. But it's a big app. It's a lot of stuff to ship. This, so I've got debug builds here, 16K. You know? And it's essentially the same code you would write if you were going to write this in Ruby. But compiling it straight down, we don't have to worry about all the extra dependencies on a Ruby runtime. Hey, Woody, where would I go? Let's see. Let's take a look at Dubious. That would be good. And that's on the Mirah account, right? Let's take a look at this one. I'll just look at the code here. So on the web side, Dubious is a little framework that's written pretty much all in Mirah, but doesn't have the dependencies on a runtime library, other than a few little things that it ships with. Doesn't have a language runtime that it requires, and it runs really fast because it compiles everything to Java code. So let's make this bigger so you can see. All right, so here we go. Again, like we did with Mirah, we like Ruby syntax, we like the way it feels. Let's start from there. Woody decided he likes the way Rails applications are laid out, the way they're structured. Let's start with that and see if we can actually do the entire application in Mirah instead of doing Rails. Let's take a look at a controller here. Contacts is the good one here. Contacts controller.
It might be easier to browse the actual app.
You have the generated Java code in there too, right? All right. So what was it? Dubious. Demo.spot.com. All right, here we go. He even sort of copied the Rails front page. Isn't that adorable? Okay, so here's our app structure. And now in here, we can take a look at our context controller. Even got syntax highlighting. And largely, again, it looks like Ruby. It looks like you're writing a Rails application. Index, show, new, etc. We got some of these things. What are these curious things down at the bottom? Looks like they're pulling out some templates of some kind, right? And what do those do? Let's go back and take a look. And like I say, this all can compile straight down to Java source if you like. You can go to JVM bytecode, but you can also compile it to Java source. If you take context controller and turn it into Java source, this is what you get out. So we've got our index logic. It's actually pulling out a data model here. If we go down and see the different ERBs that were pulled in, the different templates. It's done all of the inclusion of that into this controller, done all the extra logic of turning it into string appends, string buffer appends, string builder appends. And this is essentially all you really need out of this application. But this is the only dependencies you have, other than the Google App Engine stuff that it's running with. You've taken what looks exactly like a Rails app and feels almost as nice as building a Rails app and compiled it straight down to Java source or JVM bytecode. That's the goal with Mirah. All right. So a little bit about the code base and how it works. We're using JRuby's parser right now. Probably going to be reworking that so we have a little bit more flexibility to add minor syntax changes. Like I said, there's a JVM bytecode and a Java source backend. There's also been prototype, proof of concept work to do a C# source code backend. Again, since it doesn't have any specific dependency on the platform or on the type system, you could use the same syntax with different libraries, slightly different inference engine, and output code for other platforms. That's another goal that may come along in the future. Essentially, it does AST transformation, takes the Ruby AST, turns it into our parser neutral Doobie AST in the middle, or Mirah AST in the middle, runs type inference over that depending on what the platform is that we're running on, and then generates the code. And at this point, for everything that you've seen here, we've got a Mirah code base with the JVM bytecode and Java source backends. That's essentially 10,000 lines of Ruby code. Type inference is all written in Ruby. The code that drives the code generation, not the ASM library itself, but the code that drives that generation is written in Ruby. The AST is Ruby. So here's the basic sequence. Ruby with type annotations and our modified parser. Comes out and we get a Ruby AST with type nodes. That goes through our transformer to the Doobie AST, and we have various plugins along the way and macros that can do sort of compile time, transform time modifications to the code. We run it through the type inference logic, which again can have platform-specific plugins or crazy wild type systems if you like. And we get our typed AST out of that. And then we generate whatever the native code is for the backend. Since we have all the type information, we have the whole structure, we can generate just straight up statically typed JVM bytecode or Java source. So it's small, but there's a lot that you can do with this. And being small means it's very easy to add new features. The optional argument stuff I showed you, I think, was 50 lines of Ruby code to add that. It takes almost nothing to add additional features to the language. How much code did adding literal hashes cost, do you think? Not much. I mean, I think I added literal arrays that do the unmodifiable array list in like 30 lines of Ruby code. So you can kind of build the language the way you want. Build the language around your application or around the libraries you're running with. So places where this is being used today, the Java bits and pieces in the JRuby App Engine tooling is actually written in Mirah. I showed you Dubious. There's a contributor on the list that's actually adding the bits and pieces necessary to do GWT applications, writing in Mirah instead. I think the main thing was just getting the little inline JavaScript native things to work. Of course, I showed some early Android experiments, and it's a young code base, but there's a lot of fun stuff you can do with it, and there's a lot of hacking going on right now. All right, so I showed you the apps. Okay, so futures for this. The code base has kind of grown organically. It's still only 10,000 lines of code, but we want to clean it up a little bit and isolate the different tiers better. I mentioned the parser. I want to actually formalize and expand the type system and actually learn how to make a type system. Get the remaining features from Java, like Java 1. We're at like Java 1.0 level. There's a few little things that are above that. But figuring out whether or not we're going to do generics, enums, other Java 5 features, and additional backends and maybe even front ends. Since we have that standard AST in the middle, there's no reason we couldn't transform other syntaxes. I like the Ruby syntax. Some people are married to the curly braces and they really need curly brace syntax. But there's lots of possibilities for this. Just building up a nice tool chain that can generate all this stuff for you. All right, so then the final plugs that I'll do, and we'll have some questions. We do have a Using JRuby book that's in beta now. So if you want to get the basic overview of a lot of different areas of JRuby, you can pick that up. We had a JRuby conf for the first time last year attached to RubyConf. That was pretty exciting. This year we have 2 conferences planned already. There's JRuby Kaigi attached to Ruby Kaigi in Japan next month. And we have JRubyConf 2010 edition, which is basically taking over the Enterprise Ruby conference that takes place in Columbus. And I think we may have another one next spring, another JRubyConf in Minneapolis, where I'm from. That'll be fun too. Okay, so there's a few links, and that's about all I have. I can open up for questions on Ruby or JRuby or the state of the Ruby world or anything.
Where are you going to start to formalize? How are you going to get the process formalized in the type system?
Well, I think we're probably going to start. So the question was, how are we going to do the process of formalizing the type system? I think we'll probably start by making sure we have everything in there needed to represent at least Java 1.0 level type system. Figure out which of the features that we're doing, like some of the crazier stuff like macros and implicits and whatnot, will fit into that type system nicely. And I guess kind of just looking for suggestions on what features people are interested in from other languages, especially type system oriented ones. We don't want to go completely off the cliff and make a giant nightmarish type system that we can't manage, but we think we can add almost all of the apparent features from those different languages just by minor changes to the type system and compiler. And we're looking for folks that are interested in helping on that stuff too. Yeah, over here.
What's the advantage of having a JVM bytecode compiler versus producing the Java source and using Java C?
That's a good question. The JVM bytecode backend, the question for anybody else is, what's the advantage of having both a JVM bytecode and a Java source backend? Well, initially, since all I do all day is generate JVM bytecode, I just worked on the JVM bytecode backend. Ryan came along, Ryan Brown, who's another Google guy here, and he was interested, at least initially, I think, possibly using Mirah to do GWT stuff. So the Java source was a requirement. At this point, maybe there's not a whole lot of reason to maintain the 2 backends, but it is nice to have something that's going to do the full bytecode compilation and generation for you, rather than spitting out Java source and then having a second cycle to do the Java C compilation. If you needed to do something along the lines of having circular dependencies or having external Java dependencies that require the full build process to run together, the Java source version is also kind of a nice cheat for that. I think we've talked about only having one backend, but it really isn't a whole lot of effort to maintain both of them. And it actually kind of keeps us honest about where we implement the features of the language. If we can implement all of the features in such a way that they're mostly macros and AST transformations, then having 2 backends is easy. If we ever start to slip into one backend or the other, we know that we're tying ourselves a little bit too much to one particular format, and doing a C# backend or other backends would be more difficult at that point. So it's kind of an interesting exercise, but may actually have some benefits for the language itself. Other questions? Time is in.
We do have some more time. I could, if you guys want to see, I could dig into the App Engine app a little bit and show you how it actually works. Would you guys like to see that? Sure. Okay, and actually, if you don't mind, just bring back that browser you had.
Yeah, sure.
So this app is entirely written in Mirah. There is no Ruby in it whatsoever. The advantage to doing this is that the app spins up in about a second. Java App Engine now supports app YAML. In order to configure the app, I just modify this app YAML file. So the app itself has this little properties window that I can see what's going on. The controller that we were looking at is actually this. I'm just basically copying a scaffold generation. I don't need to fill this whole thing out. You can generate an app that looks just like your scaffold, and in this case, I've decided to use unobtrusive JavaScript. And so that's how that works. Now, Charlie showed the app earlier, how we had a controller. The views associated with that are here. I have an edit form. And in this case, I basically looked at what would the Rails scaffold generated file look like, and just try it. Just start with whatever Rails is using and then make changes in order to make it work. If I go back to the framework file itself, I have this params object. Down at the bottom here, I have this delete method. Sometimes you want to pass in an ID because you don't have it in the URL. I can generate this Java-style overloaded method chain. We wanted to create something that looked a little bit like data mapper, so my model really is just this. I have a property keyword, I specify the names of the attributes, and I specify which types they are. And you'll see here I'm using App Engine types like postal address and phone number. I also need to have those things imported, so that's what those two import statements do. Now, when I compile that, Ryan Brown's done some great work to create everything I need to access. So instead of going through data nucleus, he's just creating the methods I need based on the attributes that I defined, or the properties I defined. So if you scroll down here and notice he's got some methods where he's handling how to get a hash map of properties, or possibly set the properties, and he's generated all of this code for me. So now I don't worry about type safety. I just do something that feels like I would do with data mapper or active record, I suppose, and it's handled. All right, well, thank you very much, everybody. Thank you, Charles Nutter.